Hi guys, today this is the second episode of the math series. Today instead of one problem, I'm going to present two problems, and my solution to them. Uh, and my solution to them. Uh, where I got these problems, it's kind of same as before. I got them from the 2025 Mathemania competition past paper. And the two problems I chose were problem 17 and problem 22. Well, the ver- well, problem 17 is kind of difficult. Problem 22 is much more easier than problem 17. I think. I think. But for now, let's look at problem 17 of the 2025 Mathemania competition. Let me zoom in a little quick. If you can wait. There we go. In the following diagram is a stream code puzzle. All the numbers in a row, in a column, and a stream, that is the groups of 5 numbers shown with lines, must be different than each other, and they must be a number from 1 to 5. And then using these rules, find the number that is shown with X. So what do the rules given mean? The first rule, every number in a row must be a different number from 1 to 5. That is like, say, in the first row, all of the numbers here must be different than each other. You can't have duplicates. You can't have duplicates of any numbers. For example, you can't write 2 5s in here. That is wrong. That is wrong. You can't do that. It is said in the rules. The second rule, all numbers in the column must be different than each other. Same as the rows, but with columns. It's the same rule we used in a row, but with columns. Say I take the fifth column here. All numbers in this column must be different. You cannot write something like you can't write any duplicates of any numbers from 1 to 5. Whole numbers, I mean. You can't write 2 4s here. That is wrong. And then the very last rule. All numbers in a stream must be different each other. The stream here is the dots joined with lines like these. Like these. For your convenience, I'm going to color code each string for you to make it easier. Just wait. Don't forget to rename. This is 5. This is X. This is the third string. Don't forget to rename. This was 1. This was originally 1. And that is 3. And this last here is 3. I've now color coded the strings for you. Okay, maybe the last one wasn't that color coded. Wait. So yes, we've now fully color coded the strings. Now, using the 3 rules I mentioned before, the question asks to find the value of X. Let's do that right now. So first, we can easily deduce deduce that x cannot be x can neither be 1 or 4 because x is in the same row as 4 and in the same column as 1, and using the third and using the first and second rules mentioned before, x cannot be either of those numbers, as x must be different from those numbers. So we'll write here x can be 1 and x can be 4. So we can eliminate 4 and 1 from the multiple choices given here. So the possible values of x left is 2, 3, and 5. We can write 3 here. We can safely write 3 here because the fifth row has a 3 in it. So all the spots in that row cannot be 3. And in the string colored orange, these four slots are completely blocked from this 3. So the only place in that slot where a 3 can be put is this one. Is this one. Erase it. So okay, where do we go now? Let's look at the 4 here. The 4 blocks these columns, leaving these spots possible before. But if we take either, but both of these block, but both of those cases block this column of a possibility of 4. And so does this column can't be 4. This column can be 4. This spot can be 4 because of this 4 here. And this column can be 4 because of the 4s in here or here. I'll clear the diagram. So 4 can't be. So if 4 can't be if 4 can't be either of those. Yeah, let's look at like the I now got it now. 4 can't be this column and then in this row either, and 4 cannot be this, because of this 4. So the only spot where 4 can be placed in the purple string here is this, because all the other strings cannot be 4. We'll clear it up. This is x, by the way, not this is x, by the way. Okay, I'll lay that. We can safely write 4 here. Let's look at the red string and look at where should we put the 4. Where should we put the 4? Um, this spot can't be 4 because of this 4, because this spot is in the same column as is in the same row as 4, and this spot can't be 4 because it is in the same column as the 4 here. So the only spot that 4 can be that 4 can be in one of the spots in the red string here is this spot. So we'll safely write 4 here, and we'll erase this. Okay, we can also place 5 in one of the spots here. And we can also place 5 in this spot here because this spot cannot be 5 because this spot is in the same row as this 5 here. This last spot must be 2 as all the numbers must be different. Since all the numbers are occupied with 1, 1, 4, 5, and 3, the only number that should fit in here to complete this string is 2 to get 1, 2, 3, 4, 5. But 2 is in the same column as x, so x cannot be 2, cannot be 1, and cannot be 4. But right here, x can't be 2. We'll eliminate 2 from the list. And now, to put the final nail in the coffin, we know that this cannot. We can also place 4. We can also place 4 here, because 4 cannot be in these spots of the blue string because of these 4s. They're in the same column as these empty spaces. These two spaces here, they're in the same column as this 4, and this one spot here, this one, is in the same column as this 4 in the red string. The only spot that is free is this. It's also the only 4 in the string too. So, and then hey, look at this column here. 4 of the 5 columns are filled with numbers. So the numbers are 5, 4, 1, 3. The only number that is left is 2, free for this spot here. See, all the numbers are different. This 2 can be put here. This 2 can be put here. Okay, now finally. Okay, now this is finally. I mean, you see this green string, right? these spots can't. Oh, bruh. These spots cannot be 5 because of this 5. These two spots are in the same row as 5. And from the first rule, it says that it says that it says that all numbers in a row must be different from each other. So that means these cannot be 5. These cannot be 5 because they're already taken. These cannot be 5 because they're already taken. So the only spot that we can put 5 is this spot. But 5 is also in the same row as x. And from the first rule, and using the first rule, x cannot be 5 because x must be different from all the from numbers. But we listed here x cannot be 1, 4, and 2. And since that 5 is in the same row as x cannot be 5 too. So right here, x can't be 5. So now x cannot be four of the five possibilities that x could be. The only number that isn't eliminated is 3. You know what that means? 3 must be the value of x, as all the others are eliminated by using logic. Duh. And that is the correct answer for this problem. But before we move on to problem 2, I want to give you a challenge based on this problem. You see this diagram, right? It's fully incomplete. And I want you to complete the diagram. What I mean by that is by putting every single dot with a number from 1 to 5 using the 3 rules I mentioned before. Pause the video if you want to accept the challenge. I mean, if you finish doing the challenge, say I've completed the challenge in the comments below. And now, let's move on to problem 2. So in the given problem, all the numbers given in the following addition table represent positive integers. Given this data here, the question asks us to find the value of a. This is an addition table, so let me show you how this addition table works. You see a, right? And this a, and this plus means like you add them together in this diagram to a. There's b and b. You add them to get 2b. But what if you want to add b and a? Well, you place them in b to get A plus B. What if you want to add A with C? You write this here. Well, this is associated with A, and in the same column as C. Did you get the point? Well, I think you did. So given B plus C is 2A. B plus C is 2A. Okay? We'll write that out. B plus C is 2A. And this given here, C plus C is 12. Which C plus C is just 2C. We can divide both sides by 2. The 2 cancels out, and we get C as 12 divided by 2, or 6. We'll substitute that value to B plus C. So B plus 6 equals 2A. Wait. Sorry. I also forgot to mention this equation here. A plus B equals C. But we know that C is equal to 6 here. So we can say A plus B equals 6. Let's clean up for a little bit. Let's clean up a little bit. This turns to A plus B equals 6. Then this B plus 6 equal to A. Wait, let me do some mental math real quick. Aha! Do you see the trick? What happens in this equation? We add A to both sides. B plus 6 plus A is equal to 2A plus A. We will rearrange this to get B plus A plus 6 is equal to 3A. Is equal to 3A. We can rearrange A B plus A as A plus B because addition is commutative. So we get A plus B plus 6 equals 3A. But we know that A plus B equals 6. So substitute that value. 6 plus, okay, sorry. 6 plus 6 equals 3a, or 12 equals 3a. We divide both sides by 3. 3 cancels out with 3. And 12 divided by 3 is just 4. So the value of a is 4. And that's the answer. If you enjoyed this video, please like and subscribe. Please like and subscribe for more videos like this. Hey, as long as a challenge I as long as a challenge I offer, well, along with the challenge I offered you with on problem 17, I also wanted to know what alternate solutions you had for either of these problems. Share those alternate solutions to me in the comments below as well. I'd like to see what alternate solutions you got, guys. Come on, we all know we all know that we all know that we don't approach a problem the same way. I want to learn how you guys do it. So I'll see you in the next video. And bye bye.